This is an audio-visual presentation on transformation. Now, under transformation, we will consider reflection, rotation, translation, and enlargement. Now, let's start with reflection. 1. Reflection in the x-axis, or reflection in the line y equals 0. The rule is xy maps to x minus y. That means that x remains the same x, but the y value is negated. So xy maps to x minus y. Now, example. Reflect the point A, 3, 4 in the x-axis. So we are reflecting the point A, 3, 4 in the x-axis. And we know that reflection in the x-axis, the rule is xy maps to x minus y. That is, the x-coordinate remains the same, but the y-coordinate is negated. So now with the point A, 3, 4, the image of A will be A prime. That is 3 minus 4, because from the rule xy maps to x minus y. That is, the x-coordinate remains the same, but the y-coordinate is negated. So 3 remains the same, but the y-coordinate 4 is negated, and that is how come we have 3 minus 4. So A prime, that is the image of A, 3, 4, is 3 minus 4. Now when we go to the graph, A, 3, 4, the x-coordinate is 3 and the y-coordinate is 4. So on the x-axis we have 3 and on the y-axis we have 4. So this is the point for A, 3, 4. Now after reflecting in the x-axis, the image A prime is 3 minus 4. And 3 is the x-coordinate and minus 4 is the y-coordinate. So we have 3 on the x and minus 4 on the y. So this is the point, and that is the image. Now we have reflection in the y-axis, or reflection in the line x equals 0. For reflection in the y-axis, the rule is xy maps to minus xy. That is, you negate the x value, but the y value remains the same. You negate the x coordinate, but the y coordinate remains the same. Example. Reflect the point A, 3, 4 in the y-axis. From the rule, xy maps to minus xy. That is, you negate the x-coordinate of the point, but the y-coordinate remains the same. So given the point A, 3, 4, this maps to A prime, that is the image. We negate the x-coordinate, that is 3, and the 4 remains the same. So we have minus 3, 4. Now on the graph, the point A, 3, 4, we have 3 on the x-axis and 4 on the y-axis. That is the point A, 3, 4. But the image A prime is minus 3, 4. Minus 3 is the x-coordinate and 4 is the y-coordinate. So minus 3 on the x-axis, we have our minus 3 here. Then we have 4 on the y-axis, so we have 4 here. So where they meet, this is our point. That is the image. That is the image. So A prime is given by minus 3, 4. That is the coordinate of A prime is minus 3, 4. That is the image. Now we have reflection in the line y equals x, or reflection in the line y minus x is equal to 0. The rule is xy maps to yx. That means that the x coordinate now becomes the y coordinate, and the y coordinate now becomes the x coordinate. That means that y goes up and the x comes down. That is reflection in the line y equals x. That is the rule for reflection in the line y equals x. xy maps to yx. Now, example. Reflect the point A, 3, 4 in the line y equals x. Now, reflection in the line y equals x, the rule is xy maps to yx. That means the y coordinate goes up and the x coordinate comes down. That is the interchanging of the positions of the x and the y. So xy maps to yx. Now, with the point A, 3, 4, according to the rule, the image of A, that is A prime, will be 4, 3. That is 4 goes up and 3 comes down. The positions are interchanged. So A, that is 3, 4, maps to A prime, 4, 3. That is reflection in the line y equals x. Now, when we consider the graph, A is the point 3, 4, and the image A prime give us 4, 3. That is reflection in the line y equals x. And 4, 3, the x coordinate is 4 and the y coordinate is 3. So we have 4 as the x coordinate and the y coordinate is 3. So this is A prime, 4, 3. This is A prime, 4, 3. That is the image of the point A, 3, 4. And the reflection in the line y equals x. Now we have reflection in the line y equals minus x, or reflection in the line y plus x equals 0. The rule is xy maps to minus y minus x. That means that the positions are interchanged. The y goes up and the x comes down, but both the y and the x are all negated. That is the rule for reflection in the line y equals minus x, or reflection in the line y plus x equals 0. Now, example. Reflect the point A, 3, 4 in the line y equals minus x. So from the rule, xy maps to minus y minus x. And so if you are given the point A, 3, 4, then this maps to A prime. That is the image. So 4 goes up, 3 comes down, and the two coordinates are all negated. So we have minus 4 minus 3 according to the rule. According to the rule for reflection in the line y equals minus x. So A, 3, 4 maps to A prime, minus 4 minus 3. So from the graph, the coordinate of the point A is 3, 4. We have 3 on the x-axis and 4 on the y-axis. Now A, 3, 4 maps to A prime, minus 4 minus 3. Minus 4 is the x-coordinate and minus 3 is the y-coordinate. So we have minus 4 as our x-coordinate, minus 4 as our x-coordinate, and we have minus 3 as our y-coordinate. So this is the point. That's the image A prime, minus 4 minus 3, where minus 4 is the x-coordinate and minus 3 is the y-coordinate. So this is the image of the point A, 3, 4. Now we have reflection in the line y equals A, or reflection in the line y minus A equals 0, where A is a constant. So A is a constant. Now the rule is xy maps to x, 2a minus y. That is, the x coordinate remains the same, but the y coordinate now changes to 2a minus y, where a is a constant. So we multiply 2 by the constant a given, then we subtract the y coordinate from it, and that will give us the new y coordinate. So xy maps to x, 2a minus y. Example. Reflect the point A, 3, 4 in the line y equals 2. Now we are asked to reflect the point A, 3, 4 in the line y equals 2. That means that the constant a is now 2. Now from the rule, xy maps to x 2a minus y. So a, that is the point, with coordinate 3, 4, maps to a prime, that is the image. Take note that the x remains x, and so 3 remains 3. The s coordinate remains the same, but the y coordinate now changes to 2a minus y, where the a has now been given from the question, and from the question a is equal to 2. So instead of 2a minus y, you have 2 times 2, because a equals 2 minus y, where y is the y coordinate of the point, and the y coordinate is 4. That is how come we have minus 4. Now this maps to a prime, so we have our 3. 2 times 2 is 4, and 4 minus 4 is 0. So we have 3, 0 to be the image, that is a prime of the point 3, 4, under reflection in the line y is equal to 2. Under reflection in the line y is equal to 2. So given the point a 3, 4, the image of a 3, 4 and the reflection in the line y equals 2 give us 3, 0. The image of the point a 3, 4 is giving us a prime, that is 3, 0. 3 is the x coordinate and 0 is the y coordinate. So this is our point, 3, 0 on the x axis. So a prime is 3, 0. That is the coordinate of a prime. That is the image of 3, 4 under reflection in the line y equals 2 from the question. Now we also have reflection in the line x equals a, or reflection in the line x minus a equals 0, where a is a constant. The rule is xy maps to 2a minus x and y. That is, the x coordinate now becomes 2a minus x, but the y coordinate remains the same. That is the rule for reflection in the line x equals a, or reflection in the line x minus a is equal to 0. Example, reflect the point a 3, 4 in the line x equals 2. So from the rule, we can see that xy maps to 2a minus xy. Now we are told to reflect the point a 3, 4 in the line x equals 2. That means that a is a constant, that is 2. So wherever we see a, we have to substitute 2. xy maps to 2a minus xy. Now with the point a 3, 4, the x coordinate is 3 and the y coordinate is 4. So 2a minus x. Now a equals 2 from the question. So instead of 2a minus x, you have 2 times 2 minus 3, where 3 is the x coordinate. Then the y coordinate is 4. The y remains the same. That is why we have 4. Now 2 times 2 equals 4. And 4 minus 3 equals 1. So we have 1, 4. Therefore the image a prime of the point a 3, 4 is 1, 4. Now the coordinate of a is 3, 4. So we have 3 on the x axis and 4 on the y. This is the point. And the image a prime has now given us 1, 4. So we have 1 on the x axis and 4 on the y axis. And so this is the point a prime 1, 4. Now let's look at rotation about the origin. Now we consider the clockwise rotation. And the clockwise rotation is the way the watch moves, as is indicated by the arrow. That is the way the watch moves, the clockwise rotation about the origin. Now we have clockwise rotation of 90 degrees about the origin, the rule is xy maps to y minus x. That is, the y goes up, the x comes down, but the x coordinate is negated. Now rotate A 3, 4 through clockwise of 90 degrees about the origin. From the rule, xy maps to y minus x. That is, y goes up and x comes down, but the x coordinate is negated. So given A 3, 4, the image A prime will be 4 goes up and 3 comes down, and the coordinate 3 is negated. So A 3, 4 maps to A prime 4 minus 3. Now we have A, that is 3, 4 to be the point. And after rotating through clockwise of 90, we have A prime to be 4 minus 3. Now 4 is the x coordinate and minus 3 is the y coordinate. So we have 4 to be the x coordinate and we have minus 3 to be the y coordinate. So A prime is 4 minus 3. So now when you rotate the point A 3, 4 under clockwise of 90 degrees, we have the image A prime 4 minus 3 as seen on the graph, and the angle is 90 degrees because we are rotating this point through clockwise of 90. Now clockwise rotation of 180 degrees, the rule is xy maps to minus x minus y. That is, we negate the x and we negate the y. That is clockwise rotation of 180. So example, rotate A 3, 4 through clockwise of 180 degrees about the origin. So given the point A 3, 4, the image A prime of the point A 3, 4 according to the rule minus x minus y, the answer will be minus 3 minus 4. That is, we have to negate both the x and the y, and that is why instead of 3, 4 as the coordinate of the image A, we have A prime to be minus 3 minus 4 according to the rule. So given A to be 3, 4, A prime, that is the image of A, give us minus 3 minus 4. That is, we negate both the x and the y. So we have minus 3 minus 4. Now minus 3 is the x coordinate and minus 4 is the y coordinate. So we have minus 3 on the x axis. We have minus 3 on the x axis and we have minus 4 on the y axis. And so this is the point. And so this is the point. And the image is A prime minus 3 minus 4. So the angle is 180 degrees. The angle is 180 degrees. That is why between A and A prime is a straight line, because the angle the straight line makes is 180 degrees. Now we have clockwise rotation of 270 degrees. The rule is xy maps to minus yx. Xy maps to minus yx. That is clockwise rotation of 270 degrees. This is the rule. Xy maps to minus yx. That is, y goes up and x comes down, but we negate the y. As y goes up is negated and the x comes down. So xy maps to minus yx. That means that you negate the y coordinate and it will take the position of the x, and the x remains the same, but it will take the position of the y. So xy maps to minus yx. Now let's look at this example. Rotate A 3, 4 through clockwise of 270 degrees about the origin. Solution: given the point A 3, 4, if we are rotating the point A 3, 4 through clockwise of 270 degrees about the origin, take note that the rule is xy maps to minus yx. That is, y goes up and the x comes down, but the y is negated. So with the point A 3, 4, 4 goes up and 3 comes down, but because the y is negated, that is why we have negated the 4. So we have A 3, 4 mapping to A prime, that is minus 4, 3 according to the rule. So given A, the point A 3, 4, This maps to A prime. That is minus 4, 3. That is minus 4, 3. And minus 4 is the x coordinate and 3 is the y coordinate. So we have minus 4 on the x, we have minus 4 on the x and 3 on the y. So this is the point, and that is the image A prime minus 4, 3. Now we have rotation about the origin, that is the anti-clockwise. And anti-clockwise rotation is opposite to the way the watch moves, as indicated by the arrow. Anti-clockwise rotation of 90 degrees, the rule is xy maps to minus yx. That is, y goes up, x comes down, but the y coordinate is negated. So rotate A 3, 4 through anti-clockwise of 90 degrees about the origin. This is the solution. A 3, 4 maps to A prime. According to the rule, y goes up, x comes down, but the y is negated. So 4 goes up, 3 comes down, but the y coordinate is negated. That is, we negate the y and we take the position of the x. And that's how come we have minus 4 here. So 4 goes up, 3 comes down, and we negate the 4. So A 3, 4 maps to A prime minus 4, 3. Now B, anti-clockwise rotation of 180 degrees. XY maps to minus x minus y. That is, you negate both the x and the y, but they will take the same position. So xy maps to minus x minus y. Example, rotate A 3, 4 through anti-clockwise of 180 degrees about the origin. Now solution. With the point A 3, 4, this maps to A prime minus 3 minus 4 according to the rule xy maps to minus x minus y. That is anti-clockwise rotation of 180 degrees. Xy maps to minus x minus y. So if you are given the point A 3, 4, this maps to A prime, that is minus 3 minus 4. We negate both the x and the y coordinates. So we have A 3, 4 mapping to A prime minus 3 minus 4. Now C, anti-clockwise rotation of 270 degrees. The rule is xy maps to y minus x. Xy maps to y minus x. That is, y goes up, the x comes down, but the x coordinate is negated. Example, rotate A 3, 4 through anti-clockwise of 270 degrees about the origin. So solution, according to the rule, anti-clockwise rotation of 270 degrees about the origin is given by xy maps to y minus x. That is, y goes up, the x comes down, but the x coordinate is negated. So if you are given the point A 3, 4, according to the rule, 4 goes up, 3 comes down, but the 3 is negated. That is how come we have A prime 4 minus 3. Now let's take a look at the summary. Clockwise rotation of 90 degrees is the same as anti-clockwise rotation of 270 degrees. That is, it has the same mapping, xy maps to y minus x. 2. Clockwise rotation of 180 degrees is equal to anti-clockwise rotation of 180 degrees. It has the same rule, xy maps to minus x minus y. 3. Clockwise rotation of 270 degrees is equal to anti-clockwise rotation of 90 degrees. It has the same, the two rotations have the same mapping, xy maps to minus y x. So take note, clockwise rotation of 90 equals anti-clockwise of 270 degrees. Clockwise rotation of 180 degrees is equal to anti-clockwise rotation of 180 degrees. And clockwise rotation of 270 degrees is equal to anti-clockwise rotation of 90 degrees. Rotation about a point, say AB. Rotation about a point. Now It is not rotation about the origin, but rather about a point, say AB. Example, rotate A 35 through 90 degrees clockwise about the point 1, 2. So we are rotating the point A 35 about the point 1, 2. Now, clockwise rotation of 90 degrees, the rule is xy maps to y minus x. But before we obey the rule, we first subtract the point 1, 2 from 35. Then we rotate through 90 degrees, and at the end we add the point 1, 2 back. Now let's look at the solution so you understand it better. Solution: we are given the point 35 to rotate it through clockwise of 90 about the point 1, 2. So the first thing you have to do is to subtract the point from the coordinate of A given. So 35 minus 1, 2 is equal to 35 minus 1, 2, and 3 minus 1 is equal to 2, and 5 minus 2 is equal to 3. That means that when you subtract the point 1, 2 from the coordinate of A, that is 3, 5, the result is 2, 3. Now after getting the 2, 3, you now rotate through clockwise of 90, and the rule says xy maps to y minus x. That is, y goes up, the x comes down, but the x coordinate is negated. So if you are rotating the point 2, 3 under clockwise of 90 degrees, 3 goes up, 2 comes down, and 2 is negated. So 2, 3 maps to 3 minus 2. Now after getting 3 minus 2, first we subtracted the point 1, 2 from it. So now we are adding it back after the rotation. So 3 minus 2 plus 1, 2. Now we have 3 plus 1 minus 2 plus 2. 3 plus 1 is equal to 4, and minus 2 plus 2 is equal to 0. So when we rotate the point 35 through 90 degrees clockwise about the point 1, 2, the result is 4, 0. That is, when you consider the graph, the coordinate of the point A is 3, 5. So we have 3 on the x-axis and we have 5 on the y-axis, because 3 is the x-coordinate and 5 is the y-coordinate. So with the point A 3, 5, we have 3 on the x-axis and we have 5 on the y-axis. Now the point 1, 2, 1 is the x-coordinate and 2 is the y-coordinate. So we have 1, 2. This is the point. Now we are rotating the point A through clockwise of 90 degrees. We are rotating the point A 3, 5 about the point 1, 2 through clockwise of 90, and so we have 4, 0, and that is 4 on the x-axis. So 4, 0. So A prime is 4, 0. That is the point, and we can see that about the point 1, 2, the angle here is 90 degrees as shown. Now translation. From translation, let's take note of this. We have point plus the translation vector is equal to I. That is PT plus TV equals I, where PT is the point, TV is the translation vector, and I is the image. So if you are given the point and the translation vector, when you add your point to your translation vector, you have your image. So PT plus TV equals I. Example: find the image of the point A 3, 4. Example: find the image of the point A 3, 4 under a translation by the vector 2, 3. So from the question, we are given the point A and the coordinates are 3, 4. The coordinate is 3, 4. The x coordinate is 3 and the y coordinate is 4. Now we are given the translation vector 2, 3. We know that when we add our point to our translation vector, is equal to the image. From the question, the point is given and the point A is 3, 4. So we have 3, 4 plus the translation vector equals 2, 3. So we have 3, 4 plus 2, 3. and this is equal to 3 plus 2, 4 plus 3, and 3 plus 2 equals 5, and 4 plus 3 is equal to 7. This means that 5, 7 is the image. This means that 5, 7 is the image of the point A, 3, 4, translated by the vector 2, 3. The image is 5, 7. Now let's consider enlargement. If a point, say A, xy, is enlarged by the scale factor k, then the image is given by giving the point A, xy. If the point A, xy, is enlarged by the scale factor k, then the image will be ka. That is, we multiply the scale factor by the point. So we have ka. Now A is xy. So ka will be k times xy, and k times x is kx, and k times y is ky. That is the scale factor multiply both the x coordinate and the y coordinate. Now k times x is kx, and k times y will be ky. Example: find the image of the point A, 3, 4 being enlarged by the scale factor 2. So the point is 3, 4 and is being enlarged by the scale factor 2. Now let's look at the image. Let's look at how to find the image. Given the point A, 3, 4, the scale factor has been given to be 2. So if you want to find the image, we have to multiply the scale factor by the point. That is 2a. And this is equal to 2 times 3, 4. Because the coordinate of A is 3, 4. So we have 2 times 3, 4. Now the scale factor multiplies both the x coordinate and the y coordinate. So 2 times 3 equals 6. And 2 times 4 equals 8. So 6, 8 is the image. So A prime is 6, 8. Where the x coordinate is 6 and the y coordinate is 8. So A prime is 6, 8. Now example: ABC is a triangle with A 1, 1, B 3, 1, and C 2, 4. Find the image A1, B1, C1 of triangle ABC when it is rotated through clockwise of 90 degrees about the origin. Through clockwise of 90 degrees about the origin. So from the question, ABC is a triangle. So the vertices are A 1, 1, B 3, 1, and C 2, 4. Now we have to find the image A prime, B prime, C prime of triangle ABC when it is rotated through clockwise of 90 degrees about the origin. Now let's look at the solution. Clockwise rotation of 90 degrees about the origin. The rule is xy maps to y minus x. That is, y goes up, x comes down, but the x coordinate is negated. But the x is negated. That is, y goes up, x comes down, and we negate the x that is coming down. Now with the point A 1, 1, the image will be 1 minus 1 because 1 goes up, the 1 comes down, and we negate it. So A prime will be 1 minus 1. So A prime is 1 minus 1. Now B is 3, 1. According to the rule, the y coordinate becomes the x. So we have 1. And the x coordinate becomes the y, but is negated. So we have minus 3. So B prime is 1 minus 3. Now with C 2, 4, the image C prime will be 4 minus 2. That is, 4 goes up, 2 comes down, and the 2 is negated. So we have C prime to be 4 minus 2. Now these are the images. So the image of A is A prime 1 minus 1. The image of B is B prime 1 minus 3. And the image of C is C prime 4 minus 2. Now on the graph, we have 1, 1. That is 1 on the x-axis, 1 on the y. This is the point. We also have 3, 1. 3 on the x, 1 on the y. and we have 2, 4. That is 2 on the x, 4 on the y. Now these are the 3 points, so we join them to form the triangle. Now we have to rotate this triangle through 90 degrees clockwise, and according to the rule, these are the coordinates we have. We have a prime 1 minus 1, we have b prime 1 minus 3, and we have c prime 4 minus 2. So after rotating triangle ABC in the clockwise of 90, this is the position of the new triangle, and that is the quadrant in which it falls. Now considering this graph, this is a rectangle. The coordinate of A, we have 1, 1. Coordinate of B is 2, 1. Coordinate of C is 2, 4. And the coordinate of D is 1, 4. Now for your exercise, rotate this rectangle ABCD through clockwise of 90 degrees and see the vertices that you are going to get in order to have the triangle, in order to have the rectangle as shown. I repeat, rotate the rectangle with the vertices A, B, C, D given in the clockwise rotation of 90 to see the vertices you are going to get as shown by the rectangle in this quadrant. So you find the vertices 1, 2, 3, 4 after rotating A, B, C, D in the clockwise rotation of 90 degrees about the origin. This is the end of our presentation on transformation.